Now let us start. The third applications of the dimensional analysis is to derive relations among the physical quantities. Let us start one example. Uh, suppose a pendulum. Suppose a pendulum is oscillating. This is our pendulum. Length of the string of this pendulum is L, and this is the bob. Bob has the mass M. If I displace the pendulum from its main position, it will oscillate. So we have to derive a relations between the length L, mass M, and the acceleration due to gravity, which is acting vertically downwards. So we have to derive the relations among these physical quantity, that is the length, mass, and g. So first of all, the dimensions of g is LT minus 2. So here the power of L will be the dimension of L1, and the power of T will be the dimension of time in G, which is minus 2. So therefore the 1 is the dimension in length in G, and minus 2 is the dimension of time in G. So dimension of length will be 1, dimension of T will be minus 2. So let us start how to calculate the relations between these two variables. So time period represent normally T, L raised to the power A, G raised to the power B, and mass raised to the power C. So the T is equal to K constant of proportionality which is dimensionless constant of proportionality. Which is dimensionless. In our left hand side we have the time. So dimension of time in our left hand side is T, and we say that M raised to the power 0, there is no dimension of length, and time has the dimension 1. So this is the dimensional formula of the left hand side, that is the time period, T for the time period. Now in our right hand side we have the dimension. Right hand side we have in equation number first, K dimensionless, L for the length, G for gravity, M is the mass. L has the dimension, and its power is a length raised to the power A, and acceleration due to gravity LT minus 2. This is the acceleration due to gravity raised to the power B, and at the end this is the mass raised to the power C. So if I simplify this, add the like term, L raised to the power A plus B, and time as minus 2B, mass as C. So therefore the dimension of length is A plus B, dimension of time will be minus 2B, dimension of mass will be C. So By the principle of homogeneity, we say that if two sides, if left hand side is equal to right hand side, will only be possible when the dimension of MLT, MT and L will be the same as that of the dimension of MLT in the left hand side. So now in your left hand side we have m raised to the power 0, L raised to the power 0, T raised to the power 1. In our right hand side, a plus b, T raised to the power minus 2b. If I equate the power of respective terms, length has the power a plus b and here 0. Therefore, by the principle of homogeneity, we have to equate the powers, the dimension, both the side of the same term. Length has a plus b, here length has 0. Therefore, a plus b equal to 0. And time has minus 2b, here time has 1. Therefore, minus 2b is equal to 1. From here, b will be minus 1 by 2. And mass has the dimension c. So here, mass has the dimension 0. Therefore, c will be 0. If I calculate all these values from here, a is equal to minus 2b and b is equal to minus half. Therefore, it becomes half. And dimension b has the value minus half, c has the value equal to 0. If I place all these values in relation number 1, this is the equation number first, I will be able to find out the relations between length, gravity and mass. Finally, if I place all these values ABC in equation number first, so I will be able to find the value of t. Therefore, time will be k L raised to the power a has the value half, and g raised to the power b, here b has the value minus half, so g raised to the minus half, and the value of c equal to 0. Therefore, m raised to the power 0. If any power of a physical quantity is 0, its value becomes 1. Therefore, it comes out k power half, g raised to the power half, and minus half. It is into 1. So finally, it becomes, and now it becomes finally k root L by g. So k has the value by experimentally we can calculate the value of k. The value k comes out experimentally 2 pi. If I place this value, 2 pi is here, so I will get the time period of the oscillation of this simple pendulum. So in this way, I have calculated the time period of the simple pendulums by the application of the dimensional analysis.